In the last module, we talked about propositions and how we can connect them using different operators. Today, we are going to talk about tautologies and contradictions. So, essentially, a tautology is a statement that is always going to be true. A contradiction is a statement that is always going to be false. Before we can define what a tautology is, we need to define what a well-formed formula is. So essentially think about it like in English, I can just concatenate a bunch of different words, but that doesn't necessarily mean something. Like if I wrote I ate apple, it means something. If I wrote I apple yellow, it doesn't mean anything because it's not a valid way of putting things together. A well-formed formula is basically saying the same thing but in the context of formulae associated with Boolean logic, formulae associated with propositional logic. So what do we want in a well-formed formula? In a well-formed formula, we want things to be clear in terms of how we evaluate different things. So for example, if I have a NOT operator, it's supposed to take one parameter. If I have an OR operator, it's supposed to take two parameters. Essentially, I want things that make sense when I put it together. So this is sort of a formal definition of it. A well-formed formula can be generated by using one or more rules finitely many times. So we can have proposition that by itself is a well-formed formula. If I have a well-formed formula, I can apply negation to it. I can take two well-formed formulas and combine them using AND, OR, implies, biconditional, and any other operators we may have defined. Here are some examples of well-formed formula. We can have not of P or Q, not P and not Q, P or Q and R, etc. You can have some instances that are not well-formed formula. So here this is not well-formed because I have this two ORs in the middle. That doesn't make sense. Here I don't have an operator. I have a parenthesis mismatch. Here I have a parenthesis mismatch where I started with a closing parenthesis, etc. Now, when we have multiple operators, it's a good idea to define precedence between them. So we can have the highest order is parenthesis, then negation, conjunction prior to disjunction, and conditionals are the last. So you can have all this in this sort of a table. Negation is the highest operator after parenthesis, then conjunction, then disjunction, then implication, and equivalence. This is something that is good to know when you're reading the book. However, in this class, I will not put questions to you where you will need to necessarily know this. I will always put a parenthesis whenever there is any formula that I'm writing with multiple operators, and you should do the same thing. But this is something good to know, so I'm putting this here. Now let's define what a tautology, contradiction, and a contingency is. Intuitively, tautology is something that is always true, contradiction is always false, contingency may be true, may be false, depending on how things go. So definition of tautology is it's a well-formed formula. So we need it to be WFF, that's essential. And it is going to evaluate to true regardless of how we assign truth values to the propositions. So if I have two propositions, I'll have to look at four possible values of truth value assignment. In all those cases, the proposition should evaluate to true. If that happens, we call it a tautology. If it fails even in one case, we don't call it a tautology. So tautology is a proposition which is going to be true no matter what the values of the atomic propositions is going to be. And by the way, the atomic propositions are like the variables p, q, r that we talked about earlier. A contradiction is something that is always going to evaluate to false, and a compound proposition that is neither tautology nor contradiction is what we call contingency. Basically means that it could be true some cases, it could be false in some cases. Let's look at a few examples of well-formed propositions and tautologies. So let's see which of these is a tautology. So let's say if I say the proposition Sarah has red hair. Well, we don't know who Sarah is or whether she has red hair or not. So this is not a tautology. It could be true, it could be false. We are assuming here that we are talking about a specific person named Sarah. If I say 1 is not equal to 2, this is a tautology. It's always true no matter what, and its truth is based on the number system. Now, if I say Sarah has red hair or she does not have red hair, this is a tautology because either Sarah will have a red hair or either she wouldn't, and we have an or which is an inclusive or, and one of the propositions is going to be true, therefore this whole proposition is going to be true as well. Once again, we are at the check before you go ahead slide. Complete these sentences and identify which are tautologies or contradictions or contingencies. Once again, the answers are there at the bottom. If there is a question, make sure you ask me or the TA.